In this demonstration, we're going to show the various images that are formed by a thin converging lens when an object is located at particular distances away from the lens. And we're going to find out that it's very dependent upon the distance of the object from the lens. So we're going to go through several scenarios and see what happens. So I've labeled the thin lens, and I've labeled the focal points and the radii of curvature. And the first scenario we'll consider is when an object is located between the focal point and the thin lens. And mathematically, we can figure this out by the thin lens equation, which is just 1 over p plus 1 over q equal to 1 over the focal length. So this p is the object's distance away from the thin lens. The q is the image distance away from the lens. And then the script s is the focal length of the lens. So the first scenario we'll consider is when the object is between the focal point and the thin lens. So here's our setup, and we have our thin lens that's converging, and our object is going to be this candle here. And we're just going to position this lens at various distances away from the object and trying to find where the image results. And we've dimmed the lights a little bit so that you can better see the resultant image. So the focal length of this particular lens is 17 centimeters. And remember, in our first scenario, we're going to determine where the image forms when the object is located within a focal length, so within 17 centimeters. So I'm going to position the lens at this position is 17 centimeters, and I'm going to position the lens right around here. So let's look for the image. So I'm going to position the screen at various positions away from the lens. And you can see that there is light getting through the lens, but none of this light looks like the candle. So the image isn't really formed. And in fact, I could take this out to infinity and you would never see a resulting image. So where is the image? Well, the image forms when actually on the other side of the lens. So as you can see, the resulting image is formed on the same side as the object. And when this occurs, this is referred to as a virtual image. And you will also see that the image is larger than the original object. So we say that the object's been magnified. And this occurs for converging lenses when the object is within one focal length away from the lens. And I can move the lens at various distances away until I get to one focal length. And when I'm at one focal length away, you'll see that the image disappears. And if I move past the focal length, you'll see that the image does not return. So we'll have to consider those cases next. Now in this scenario, we're going to analyze where the image forms when the object is placed somewhere between the radius of curvature and the focal length. So in this case, I've placed the thin lens somewhere just past the focal length so that the object is here, and we're going to find where the image forms. So I'm going to move the screen until I think I see an image of the candle. And you can see that at a particular point, the image forms. And because the image forms on the opposite side of the lens as where the object's located, this is referred to as a real image. And it's real because you can put any screen here and it's an actual image that forms. Unlike the previous case where the image formed on the same side of the object and you had to look through the lens in order to see the image. So in this case, you can see that the image formed is inverted and it's also magnified. It's bigger than the object. And if I move the screen at any other location, the image disappears. So it's only at one particular location, as described by the lens equation, when the object is located between the focal point and the radius of curvature. In the final case, we'll see where the image forms when I place the object past 2 focal lengths away or past the radius of curvature of the lens. So here's my thin lens, and I've positioned it just past 2 focal lengths away from the object. And now let's find where the image forms. So currently we don't see any image, we just see a blur. And I'm going to slowly move this towards the lens until I see the image. Now, this image, since it forms on the opposite side of the lens as the object, is still a real image, and it's still inverted. However, as you notice, that the size of the image has been drastically reduced from the size of the object. And this occurs when the object is placed past 2 focal lengths away from the lens.